Okay, good afternoon, everyone. Have you heard before, I'm talking about, again, ground penetrating radar on the moon, but I want to give the focus that data integration plays an essential role in the interpretation process of a radar dataset. Quick overview of what we are going to talk about. First of all, I'm going to give a quick review of the geological setting of the landing site in order to get the basis for data integration of kind of subsurface data and superficial data, both from a regional point of view and from a local point of view. And we are going to see the correlation between these two kinds of data. At last, we are going to give a look to the last lunar penetrating radar release up to heard before last night. Okay, focusing on the landing site, as you probably all know, the von Karman crater is located in the South Pole Aitken Basin, which is considered the oldest and likely the largest and likely the oldest impact on the moon. This entire landing area exhibits some complex superimposition of impact morphologies, especially from the neighbor impact of Leibniz and Vincennes crater, whose ejecta fill and affects the morphology of this entire area. Recently, Chang and others in 2018 described the geological setting of this area, especially in terms of Vincennes ejecta. In fact, it finds the dominance of Vincennes ejecta rays on this entire area, and we can see here on these two images. We can see that in this dominance of Vincennes ejecta rays is reflected in the distribution of alternates of southwest-northeast features, which are evident on this 3D digital elevation model. We see here that the rover crosses just one of these features. In fact, it landed on a high zone, which is here in red, moved toward northwest, following a non-rectilinear path and crossing a low bridging area, which is here in blue, and is moving toward another high zone area. But the question is, knowing such in detail superficial information and topography variation, how this data helps in the interpretation of a radar data. First of all, knowing such in detail the topographic variation allows to calculate the topography correction for lunar penetrating data, which allows to get a more realistic representation of the subsurface in order to highlight the correlation between the two kinds of data. In this image, we can see the digital elevation model in the same color as before. So red is a higher zone and blue the lower one. And we can see that below we have the reconstruction with the topography correction of the lunar penetrating radar data. And we can clearly see that below high zone, there is but below high zone and low zone, there is an alternance of internal unit in terms of presence or absence of this high scatter unit. The interesting point is that this regional trend in terms of alternance of presence or absence of units can be found not only in a regional scale, but also on local scale, as we can see in this figure, which is highlighted by the black arrow here, in correlation with the digital elevation data. But I want to focus a bit deeper in these figures, because the most important thing I think there is in this figure is this unit characterized by this light green reflector, which occurs to be the highest lateral continuous and the highest amplitude reflector of all the LPR data. This unit is characterized by a constant thickness of about 3 meters and an inclination of about 15 degrees. And it is located on top of this other spatial coherent unit, which was previously interpreted by my colleague as unit 2. This particular unit, although it's not, this particular unit, I have to say another thing before going on. This particular unit was not visible on satellite images, but it is very clear on digital elevation model data, and it's derived azimuth and slope data. This fits well with our LPR data observation, which define this unit, which is unit 2, as an old buried crater. But what is it really important is that this unit, whose top is the light green reflector, is for the first time identified as a separate unit, separate from the upper unit, which is unit 1, composed of mainly regolith, and the lower unit, which is unit 2. And according to its position, so on top of the rim of an old buried crater, we tried to associate a physical meaning to this unit, and we suppose that this unit is related to an older impact melt created on the rim of this crater, which is well imaged on deep and azimuth maps. This study was performed considering the LPR data released up to December 2021. We can see here again the same old digital map, the elevation map, considering with the red high zone and blue lower superficial zone. And we can see the data here, and we can recognize again the correspondence, the alternating with the absence or presence of unit 2 corresponding to high zone or low zone on the superficial data. So at the time, we suppose that if the rover is moved toward another high zone, which is the rover actually doing, crossing another high zone, we're supposed to find another setting as before. So the presence of, I say maybe the same U2 unit, but almost the same setting of inside the LPR data. And our supposition was confirmed with the last release last release was April 2023. And we can see here all data available up to last night. We don't have time to process and elaborate this to show to you, but our hypothesis was confirmed from the fact that this scattered unit, which is imaged here, corresponded precisely to this high zone. And we can see, oh, the mission is still going on, so we have so much time to confirm it again, this hypothesis. But what is important to say is that a corresponding between superficial data in terms of alternating of high and lower zone is reflected inside the data in terms of presence or absence of units. So what I've talked about up to now, I tried to pass the message that an integrated approach is essential, and based on data integration, it is possible to provide a better interpretation of the data. Of course, we are talking about the moon, so no one actually see what's down there. So they are all hypotheses, but we are with the integration of data coming from superficial information, subsurface information, drilling core, etc. We are much more confident in our hypothesis. So we were able to correlate the superficial morphology to subsurface lunar penetrating data and interpreted for the first time new features that in previously published paper were interpreted as totally different ways. So mission is still going on, so we have so much more to learn. Thank you everyone for the attention.